Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Right, so my name is Steve Wilson. I am working in the School of Chemistry at the University of Southampton. My PhD mainly revolves around automation and real-time monitoring of chemistry experiments. But in our research group, we are developing an ELN, and I've been developing my tools to integrate with that. So this came out as part of that. This was a little side project that actually turned out to be working quite well. So I'm going to talk about ELNs and then our particular implementation of it, and then show you our commenting on picture software, which is what I developed as a tool for it. So, as everyone likes to tell us chemists, we're terrible at recording data. We record as little as possible. We don't record any of the observations that we make, such as colour changes in reactions and exotherms, things like this, which are very useful when you come to go back to the data. And we don't record any of these supplementary informations, like the temperature in the laboratory, or more important things such as if a fire alarm's gone off during the time when you're weighing out samples and your sample gets exposed to air for longer than it does normally. This can make a massive effect on your results, and we don't tend to write these things down. And of course, we ask chemists, we generate loads of spectra, and these very rarely get copied up into our lab books. They get stored somewhere safe, and that safe place gets forgotten about, and then we have to repeat the experiments to get this data again. And this all leads to poor experimental procedures reported in the literature. So I can read a literature report about an experiment that was done at room temperature, and then I find out that it was done in California, and the room temperature in California is considerably different than it is in England. So things don't work. But not just that it affects the literature, it actually affects the researchers themselves. So if I go back to have a look at a piece of work I did a year ago, if I haven't written down all the details, then I'm going to find it very difficult to know what I did and how to repeat the experiment, which I need to. So the archiving of our data is very important. As I was saying before, the spectra tend to get lost, or if it's on a machine that's just local to your lab, you run your experiment that gets saved onto that, sometimes in a logical structure, sometimes just as raw files. You then go back to the machine and you find out that they had to remove some of the data because the machine was full, or they've now upgraded it to whatever's new, and your data is no longer there. And handwriting, I'm terrible at reading people's handwriting, so when I try and go back and look over some of the research that the guys before me have done, I can't read any of it. And again, very rarely, well, I say very rarely, that's not entirely fair, but you don't always record the correct data. So you run an experiment, you think you're recording what you need, and you find out that it's just completely wrong. If you record as much as possible, which is where my PhD comes into it, if you just record everything that you can, then you can go through and look at the different data streams at a later date should you find out you haven't recorded the right thing. And of course, things get destroyed. We're famous for our Mountbatten fire, which I'd like to point out wasn't chemistry. We're innocent. It was nothing to do with us. But I'm on the understanding that this was the largest insurance claim for research data in history. And I know loads of people who lost all of their data because it wasn't archived properly. It's terrible, but these things happen. So should be archiving it properly. So how should we be doing it? These are the guidelines that are pointed out by Dartmouth College about how they should be recording their lab books. I've highlighted a couple of areas of it, and the key words from this is that it's a permanent document, so it has to be a bound book of sorts. So no scrap paper, none of these tea room drawings that you use. And that it has to be of laboratory observations. It's not just the work that you're going to carry out, but it's what happens during that time. So again, going back to making sure you record the correct data. And then on the other section that's highlighted, it says that if you're caught using scrap paper, they'll take your lab book away from you and make you start again. So they take it very seriously in Dartmouth. And yeah, I personally have to admit that I very rarely stick to these rules, but since I started using RELN, I'm getting better at it, so they do help. So to combat this, there's been a whole number of electronic lab notebooks that have been developed. I've listed a few, there are thousands. The ones I've given pictures for are the ones that I find quite interesting. There's Vera, which is of an archaeological dig site in Silchester, and they use a whole bunch of Web 2.0 things like wikis and blogs to hold their data and for collaboration. And Cambridge Soft is obviously a massive company. They've got loads of tools that interact with the ELNs and Microsoft Word and things like this. And the More T project, which is another one that's being developed in Southampton. It's a very rigid ELN where you define your procedure and then you follow that procedure and you make the changes so that if you agree that you're going to weigh out 5 grams, you weigh out 4.9, you just enter that. And it allows you to upload some level of spectra, things like TLC plates you can draw in. But yeah. So we developed our own version in our research group, which is the use of a blog as a lab book. And you see the picture there, that is my lab book. The blog is obviously very flexible. I was saying before, the More T project was very rigid. You set your procedure, you then did it, and then you had your results. The blog allows for more different ways of approach. So when I personally use it, I have another website which holds all my data. I then just reference areas of that. Some of the biochemists that use it, they upload all their data actually into the blog, and then they can comment on that. And other groups have used it in different ways. But of course, it does require a repository. A typical blog implementation, you wouldn't have your data within the blog. You'd maybe upload pictures to Flickr or videos to YouTube and then reference them. Our implementation of it, actually the data is stored within the blog so that you've got better access to the data and you don't need to worry about putting it into these other sites. But you still need to worry about the real world. You may run into issues about IP. We try and cover this by maintaining full provenance of our blog posts. So whenever a blog post is made, it's one-way encrypted with a timestamp and the content of the blog post. So although you can't go backwards from that, you can then prove that the blog post is as it was at the time that you made it. And of course, safety documentation. We can generate the safety documentation within the blog, but then you have to have the physical version of it near the experiment. So if we do ever set fire to the chemistry department, the fire department will come and actually put our building out. And the way we do that in our blog is to use barcodes, either 2D or 3D. I've shown an example of my lab book, which is the one at the back with the 2D barcodes, and one of the other guys in our group who uses the 3D barcodes. So each one of these links back to a unique URL, which is for a particular blog post. So each one of those is a blog post. And in fact, one of the guys that's using our blog has his set up so that each one of his samples has its own unique blog post. So he can go into his fridge and get his bacteria samples, scan his barcode with his phone, and then it can bring up instantly the information about that sample. He doesn't need to worry about finding the page in the lab book. Now, of course, blogs allow you to make comments on the blog posts. Allows their supervisors to see what you're doing from anywhere in the world, and then suggest where you should be going and what you're doing wrong. They can also tell you, they can sort of push you in the right direction if they think you're going the wrong way. But of course, a standard blog only lets you comment on the content of the blog post. And chemistry is revolves heavily around the data and the spectra. So you need a way of being able to comment on pictures. So I'll just give you an example. This is from one of the labs in the university. We run TLCs. They run hundreds of these every day. They're non-permanent, so you can see these are all written on in pencil on top of the cell. And they fade fairly quickly. There's gel electrophoresis sheets, which is used for purifying DNA. Again, this one's been written on. You're not supposed to write on the slides. He managed to ruin his slides because he didn't realize you could write on it. If you'd have used our software, then you would have been able to comment on the picture afterwards. And of course, NMR spectra, we run hundreds of these as well. These get written on all the time. These are the most common thing that's lost or not referenced back to a particular sample. So you may have 100 NMR, but you don't know what it references to. So being able to link these things together is very useful. So the software that I've developed was to allow you to comment on the pictures themselves. The benefit of this is that it then lets you be able to highlight a particular section of your spectra or your results, and then you can highlight where it may have gone wrong or where it may have gone right if it's a terrible set of results, and then offer the advice of how to improve it or to understand what the data is saying. Again, this can be done remotely. You don't need to be within the same room to be able to do it. You can just comment on the picture. And the picture shown here is actually one of my bits of data from my laser experiment. And I was running the experiment while my supervisor was away in Berlin. And within about 3 hours, we'd had a full conversation about it. And I've managed to greatly improve my results because of it. So, very useful. Software itself is just a Java applet. Your base image is displayed in the background, and it uses the transparency features of Java to generate your layer, which you'll be writing your comments on. And it uses the mouse handler interface. So it just receives calls from the operating system. So it works with anything like mice or interactive pens, or in theory, touch surfaces, although we haven't tested it. You can add text onto the pictures, as you saw in the previous slide. You can either do it through typed text, as I showed, or through handwriting, if you've got a tablet or, again, a touch surface. And you can also, if you see in the top corner, you can display the comments that have already been made. So you can actually build up a sort of stack of conversations about a particular data point, and you can hide and show them so you can see what other people have said. And when you finish drawing your comment, you just hit the post button and it submits it back to the blog as if it was just a text comment, and then it gets stored in. So I'll show you some examples. Here is a HPLC trace from one of our research groups. They submitted it onto the blog so that their supervisor could have a look at it while he was away. He then looked at it and highlighted this section in the middle as an unknown and got them to do some further work on it, which they then classified as a side product. It shows how wonderful the handwriting of my colleagues are. And then just to show that all the layers can be stacked on top of each other so that you can then, as I say, build up this conversation. And again, there's another gel electrophoresis plate and the comments on it. And the researcher was trying to highlight particular areas of it to her supervisor because he didn't quite understand what she was trying to show him. So she put the comments on and then it made sense. And then as a last example, this was one of the fume hoods that we have in one of our research groups. And they are collaborating with a group in Berlin, and they were trying to describe how their fume hoods were set up. So they just took a photo and then added the comments of the sections of the fume hood and how they were running their experiments. So further work. It's a Microsoft conference, so I've got to mention Silverlight. I say it eliminates the troubles I had with Java. I know Java's supposed to be cross-platform and wonderful and work with everything, but I had a lot of trouble getting it to work in different browsers on different operating systems. There was a time when it was only working on my desktop computer. It's now working fine with all the browsers, but in theory, using Silverlight should eliminate all of that. Things should just work. Also, better interactivity with the other components. Again, it should just work rather than having to fight with Java to get things to work. And faster development execution. With the .NET stuff, it should be much quicker, more documentation, and should run faster. We're also looking at using SVGs. At the minute, it just generates PNG files. We're looking to do SVGs. So it'll make things easier to store. At the minute, we are, when you hit the post button, the image is converted to a ping, encoded, submitted to the API of the blog, and then stored. We were having troubles when we first did it that the PNG encoding was getting encrypted, and then the files was lost, and it was just giving corrupt files. So using SVG, it's just a markup language that would be much easier to handle, and in theory alleviate any of those problems. You can also then embed links into the actual comments. So when you're highlighting a particular data point or a section of your results, not just can you suggest how to improve it, but you can also then pass the people links as to ways to move forward with it and actually look at what might be causing it. And again, optimize for mobile devices. I haven't tested it on my iPhone, but to be able to draw the comments on my phone as I'm going along. Would be very useful. Yep. Okay. And just acknowledgements, I'd like to thank EPSRC for their funding, Professor Jeremy Frey, my supervisor, for his support, Andrew Milstead, who is the lead developer of the blog, and the Starts group for letting me use their spectra, which I showed.
Thank you. Are there any questions for Stephen?
Most of your input is through either handwritten or typing, but in labs people are wearing gloves, they're doing things that make writing very difficult.
Yeah.
Typing. What about an audio interface?
We haven't looked at audio, but one of the things we have been looking at is the use of some of the Wiimote software to actually use the IR pens that can be received from the Wiimote and then track that as mouse movements. That's just coming in now. I'm just finishing coding some of that, but then that will allow you, all you'd need in theory is just either a reflective something on your finger or an IR penning that you can then draw on. And that can be linked with a projector, which can then just be projected onto the side of a lab wall. And that will alleviate some of the problems, because obviously acetone destroys tablets, as we found out several times.
How many other lab mates have you gotten to use it? How pervasive is the usage?
The use of the blog itself has got quite large now. I think there's around 30 blogs. The use of the comment software hasn't been huge at the minute. I'm not entirely sure why. There were issues with it in the development in the early stages. Obviously, I was saying that it wasn't working with certain browsers. And yeah, I don't know why, but there are around 4 or 5 people who are using it on a regular basis now. Yeah.
So the comments are stored embedded with the image, are they, as opposed to being stored in a database or on a server?
Well, the data items themselves are stored in a database, which the blog then which pulls from the blogs pull from the database, and the comments on the images are also stored in the database, but they are stored separately from the image. So in my examples, I'll show so here, this references. You can either tick this or untick this, and it'll hide and show the image. So they are separate things.
So you're using. So you still have a logbook.
I still keep a logbook, not a lab book.
Right. Okay.
So I log everything I do, but the blog is my lab book.
Right.
And there is a slight difference in the two.
All right. Thank you again, Stephen.